Hey everybody! We're now going to look at why do objects actually orbit each other. So why do planets orbit around the sun? Why do moons orbit planets? Well, I've mentioned it a few times, and it's down to gravity. And gravity is a force. So in physics, a force, scientists say it's something that causes a push, a pull, or a twist on an object. And gravity is a pulling force. So if an object, well, every object has gravity, and if an object is big enough, then it's going to have a really strong gravitational pull on other objects that are nearby. And the sun is the biggest object in our solar system, and it's got the greatest gravity by far. So the sun has this huge gravitational pull, so that any objects nearby are being pulled in, and they're basically falling into the sun. So let's think about what that means. So gravity, it pulls nearby objects inward. Alright, so if we're in a spaceship and we're flying near the sun, let's give us a little rocket ship. Okay, so if we're flying along in our rocket ship, if we have enough speed, we'll be flying close to the sun. The sun's gravity is going to pull us in closer, but if we have enough speed, we'll be able to break that gravity and keep going. And we'll be able to pull away from the sun. So, objects with enough gravity, with enough speed and momentum, they'll be pulled towards an object, but they'll be able to keep going. Okay, but then there's the other option, where if we're in a really slow flying spaceship, so if there's another one coming along, let's say we're in a really slow looking ship, it's trying to fly, but it doesn't have enough speed. Well, as we're flying past the sun, we're just going to be pulled in, and we're eventually going to hit the sun because we don't have enough speed to fly past it and escape the gravity. So not enough momentum means we're going to be pulled in and we're going to hit the object. So we don't have enough momentum. We're going to be pulled in and we're basically going to fall into the sun. Fall into it and hit it. Okay, obviously that's not what we want to do. But there's a third option. So if there's a perfect balance between the momentum that you have and the pull of gravity, then you can get stuck in an orbit. And this is what's happened to all the planets. So here is an example. Actually, let's have a look with the sun again firstly. So if we have the sun, if we're flying along in our spaceship, and this time our spaceship is perfectly balanced . Here we go. So our spaceship has the perfect amount of momentum and speed that it balances gravity. So now we're going to fly past the sun and we're going to be pulled in towards the sun, but we have enough speed that we don't escape, but we don't fall into the sun either. So we're just going to go in a complete orbit, and then that circle is going to continue and continue and continue. So we'll be in orbit. So this is the third option. The first one is if you've got too much momentum, you'll fly past. Second one, not enough momentum, you'll fall in. The third one, you'll enter your orbit. So if momentum, if it balances out with gravity, the object will enter an orbit. So this is how we send up satellites to go around the Earth. We give them exactly enough speed so that they end up orbiting the Earth for years and years at a time. So we can use them for our telecommunications and GPS. So this is how the Moon orbits the Earth in exactly the same way. There's the gravitational pull of the Earth that's pulling on the Moon all the time, but the Moon has its own momentum and it's moving sideways. So these two forces balance out perfectly so that the Moon just follows its orbit around the Earth. As we know, it does one orbit every month. So these two examples of an orbit basically look like a perfect circle, but actually scientists have figured out that orbits don't have to be circular. And the shape they're called is an ellipse, or the other way to say it is orbits are elliptical. So in geometry, an ellipse is just basically a flattened circle. It can be flattened a lot, or flattened less, and then a circle is basically an even ellipse. Just like how you have a square, which is even on all sides, but a square is still a rectangle. So a circle is still an ellipse, it's just a perfectly even ellipse. Okay, and a few objects in the solar system have really obvious elliptical orbits. So here's Mercury's orbit. You can see it's almost circular, but it's not lined up in the middle with the sun. So Mercury has a point where it's really close to the sun, and then it gets quite a bit further away at the other side. Comets have really obvious elliptical orbits. So here are a couple of comets in the solar system, and Halley's comet's really famous. So Halley's comet, it orbits really close to the sun, and then it slingshots way back out past Neptune, and then turns around and comes right back in again. Same with this comet here too. This one goes way out past Neptune and into the Kuiper belt. So every orbit is elliptical, but some are more circular than others. The Earth and most of the planets, they're almost circular, but they're not exactly perfect.